Here in Chapter 2, we will define our trig functions in a little bit different way than we did in Section 1.3. In Section 1.3, we use a point on the terminal side of the angle to define our trig functions. You can see down here in the box we had y divided by r divided by y, and everything was in terms of x's and y's relating to the point that we picked on the terminal side. Here in this section, we will define them in terms of solely the right triangle itself. So here is our angle A, and looking at our angle A here in standard position, we really want to work with the right triangle that is formed by using the point that we picked on the terminal side and using the distance in the y direction and the x direction, and our r, the distance from the point that we picked to our vertex. We wanted to work with in terms of this right triangle. So if this is my angle A that I pick, we know that sine is y over r. Well, y would be the side that is opposite, meaning not touching the angle, so it's opposite of the angle. And our hypotenuse, of course, is the side that is across from our right angle. So r would be our hypotenuse. So since sine was defined as y over r, we are now going to define it in this section as the opposite side of the angle divided by the hypotenuse. Also for this angle, we will have an adjacent side. The adjacent side will be the side that is touching the angle. So the side that is adjacent to angle A will be our x distance. So cosine we defined as x over r. Well, in this section we're going to look at it as the side that is adjacent to angle A divided by the hypotenuse. And tangent now will be the side that is opposite of the angle divided by the side that is adjacent to the angle. And of course we have all of our reciprocal functions defined in a similar manner. Here in example 1, we will use our new way of defining trig functions to solve for the sine, cosine, and tangent of both angle A and angle B. So let's start with our angle A. So we want to find sine of angle A. So here's my angle A. We want to identify the side that is opposite of our angle A, and that would be right here. And the side that is adjacent to our angle A would be right here, the side that is touching our angle A. The side that is across from our right angle is always the hypotenuse. Now we have all three sides labeled, and we can now form our trig functions. So sine of angle A would be the side that is opposite divided by the hypotenuse. So that would be 36 divided by 85. Cosine would be the side that is adjacent divided by the hypotenuse. So that will be 77 divided by 85. Tangent will be opposite over adjacent. The opposite would be 36, and the adjacent side would be 77. Here's where the words SOHCAHTOA come in. If you use S to mean sine, so this would be our SO, OA, OH, that's our SO, CA, so that's cosine, and then adjacent hypotenuse, and then TOA, that's the T for tangent, and then the O and the A for opposite over adjacent. Alright, now for sine B, cosine of B, and tangent of B, we are going to work from the angle B this time. The hypotenuse will stay the same, because that will still be the side that is across from our right angle, but this time we're going to work from the perspective of angle B. And now, going across, 77, this side will now be the opposite side, and our adjacent will be now the side that is touching angle B. So sine of angle B will be opposite over hypotenuse. So now the opposite side will be 77, and our hypotenuse is 85. The cosine of angle B will be adjacent over hypotenuse, and that will be 36 divided by 85. And tangent of B now will be opposite over adjacent, so the opposite side 77 and our adjacent side 36. One thing that we notice is, since we're working within the same right triangle, that sine of angle A is the same as the cosine of angle B. And the cosine of angle A is the same as the sine of angle B. This is something that we will work with in the future called cofunctions. We just want to observe for now that those are similar values. Suppose ABC is a right triangle with sides of length A, B, and C with right angle at C. Here we are given capital A, capital B, capital C to represent the angles of our right triangle, and lowercase a, b, and c to represent the sides of our right triangle. And it tells us that our right angle is at C. So let's draw a picture here. Here's our right angle. We will call that angle C. Let's call this angle A and call this angle B. It doesn't matter the order of angle A and angle B. And now we're going to label our sides. And traditionally, across from angle A, this would be what we would call side A. Across the opposite side for angle B, we would call that side B. And across from angle C, we would call that side C. So we are told that side A is 6 units long, side C is 7 units long, and we are told to find side B using the Pythagorean theorem. So our Pythagorean theorem would be a squared plus b squared is equal to our hypotenuse c squared. So that would be 6 squared plus b squared is equal to 7 squared. So we get 36 plus b squared is equal to 49. And I want to subtract 36 from both sides. We get b squared is equal to 13. And now I want to take the square root of both sides. So we get that b is equal to the square root of 13. Now we know our sides of our right triangle, and we want to form the sine, cosine, tangent, and the reciprocal functions. We want to form those function values from the perspective of angle B. So sine of angle B, we need to find the opposite over the hypotenuse, and the side that is opposite of angle B, since we're working from the perspective of angle B, we found that to be the square root of 13. So that would be the square root of 13 divided by the hypotenuse, which is 7. For cosine of B, we want adjacent over hypotenuse. And the adjacent side would be the side that is touching B. That would be side A, which is a value of 6, divided by our hypotenuse, which is 7. And tangent would be opposite over adjacent. And the side that is opposite would be square root of 13, and the side that is adjacent would be 6. So we have sine, cosine, and tangent of angle B. Now we will, it should be square root of 13 up here for sine. So now we will take the reciprocal of our sine, cosine, and tangent functions. So cosecant of angle B Well, sine was square root of 13 divided by 7, so cosecant of angle B will be 7 divided by the square root of 13. And we talked about we want to rationalize, we want to get rid of that radical. So we'll multiply top and the bottom by the square root of 13, and that gives us 7 times the square root of 13 divided by 13. Secant of angle B will be the reciprocal of cosine, so that would be 7 divided by 6. And cotangent of angle B will be the reciprocal of tangent, so that would be 6 divided by the square root of 13. And once again, we want to rationalize our denominator. Multiply top and the bottom by the square root of 13. And we get a cotangent value of 6 times the square root of 13 divided by 13.